of the opponent. Also challenge.
We would like to challenge water bottle rocket. Problem number 14.
We reject it.
那我想，Let me think.
We would like to challenge number 11, spring characteristics. We accept it. And the reporter has 5 minutes to prepare. And please write down your names, the center's names on blackboard.
我没有那么脆。对哦，在这里，在手部希望，谢谢。OK， 好的，再报告。
Conan, please put down your name on the blackboard. Before the freestyle the stage, you have 12 minutes.
Okay. Hello everyone. I'm from National Campus Senior High School, and our team is Poseidon. And my name is Chen Wei Chen. And today we are showing you our topic is spring hysteresis. And this is problem statement. Okay, first we connect to identical linear spring symmetrically to the mass in a V shape, and apply an adjustable force to the mass. And when this force is varied, the resulting motion of the mass depends on the history of change in the applied force under certain conditions, and investigate this phenomenon. Okay, according to the above article, we can find some key points, and the shape must be in the V. The spring must be in a V-shaped spring, and we use adjustable for extra force to the mass, and find what will happen in this system. Okay, and just like this. Okay. So just like this video, just like this picture can show you the whole phenomenon. Okay. And what is hysteresis? According to the reference, a variation of the external force causes the system to undergo several new modifications at two different critical points, leading separately to a certain and destruction of the plunge of stable equilibria. And you can look at this picture, and when the x-axis is extra force, and the y-axis is our ball's direction. And when our extra force is want to pull the object down, and when our extra force is equal to F2, there will happen the settle new application. And then we define the settle new application is the whole system's parameter is changed. There will happen the unstable equilibria in this system. So we find this point will happen in the F2. That's all. And we use free mass hysteresis simulation to simulate hysteresis. And you can see this video. And when adjustable force is here, and then we want to pull the ball upward, and then you can see this data has changed. And when our extra force is changed to the 10 Newton, and there will happen the unstable point in this system. That's okay. And and then we want to find this phenomena in a real condition. And so we pull the mass vertically down to a certain place and release it to check the motion of the object and the red point on the spring to see whether it has spring hysteresis. And so we use this extra force to pull the ball down and then relax. So the ball will shake up and down, and then we check the red point of the spring and want to find if there is hysteresis phenomenon. And we can start in the initial the tracker. We can find there actually has unstable phenomena in our experiment, and so next page. So we thought the hysteresis phenomena will happen in the initial oscillation. So we use experiment to want to prove this phenomena, and this is our force sensor, we make our spring in a V shape and stretch them up and down, and to want to find this phenomenon. And this is our experimental procedures. And first, we stretching and relieving spring at some displacement, and recording the force gap between them. And we define the force gap is hysteresis of hysteresis phenomena. And if we stretch the spring to the 3 centimeter and replace them and relieve them at 3 centimeter, and we find if there has a force gap between them, and then compare comparing if force gap gets better when we pull and relieve the spring more time, because we found hysteresis phenomena will happen in the initial experiment. And here you have a question is what do we show our extra force is in the some direction, and we use this triangle support to anchor the direction of extra force, just like this video. Okay, next question. Okay, this is our variable 1. And our independent variable is stretch time. And our control variable is some kind of spring, force sensor, operator, and strangle support. And our dependent variable is force gap between pulling and relieving. And you can see this is our experiment result. And we find hysteresis occurs the part of the substance energy to be converted into heat energy. And you can see this diagram. You can see that they actually have the force gap between this point and this point. But when we do more the experiment, the hysteresis phenomena can be inapparent. And this is you can see this diagram is our pulling condition is the blue line, and our relieving condition is the orange line. And we can see the blue line is greater than the orange line, and we see this is the hysteresis phenomena of the spring. And this is our variable 2. And our independent variable is different content of spring. So we focus hysteresis phenomena will happen in the ball and in the system and in the spring. So our control variable is some kind of spring for sensor and operator. And our dependent variable is force gap between pulling and relieving. So we do this experiment. We want to solve different kind of spring will cause to hysteresis phenomena. And we use different size of spring, and one is middle size spring, and its K constant is 156.8 Newton per meter, and the small size spring's K is constant is 275.6 Newton per meter. And this is our experimental data. And when the K constant is smaller, the hysteresis phenomena is inapparent, because we thought the hysteresis the lowercase spring because we saw the lowercase spring when we stretch it, they didn't they are easy to stretch, so we thought the hysteresis phenomena is inapparent in the small case spring. Yes. And this is our conclusion. As we stretch the spring more times, the hysteresis effort became inapparent. And the second is, as the spring constant value becomes smaller, the hysteresis effort of the spring becomes pronounced.
Should we move on?
My question, your question.
Is the spring compressible?
Compressible?
Yeah.
Spring.
So you can compress the spring and
Yeah. Yes.
Okay. So another one is, does the force sensor influence the mass?
Influence the mass.
Yeah.
You say the both mass?
Yeah.
We saw not.
So there's you use force sensor to measure the mass. Force exerted on mass.
In the
Okay. Next one. What is your definition of the force gap?
force gap, look at this diagram, force gap. Because this is our time, and this is our force, and this is our flowing line, and this is relieving line, and this is the sun displacement. And we define, in the sun displacement, our flowing, and we, how we use force will, in the flowing line will better than, will greater than the relieving line.
Okay, so, okay, next question. Did you consider the fatigue effect of the spring?
Fatigue effect?
Yeah, just the spring will fatigue.
Fatigue, quite
Just non-linear. You stretch it and it's broken. Yeah.
it's broken.
It's not anything. F equals.
Oh yeah, maybe you will.
You do consider.
Yeah, we consider.
Oh, so okay. Okay, so how did you measure your heat energy? You mentioned the energy will for you.
And is we thought it will be transferred to the
Time's up. So component has 3 minutes to prepare presentation. Hello everyone, I'm the opponent of the spring hydrolysis, and we are from Team of Plastic. carbon is their carbon recap, and the reported key point is on the V-shaped spring, adjustable extra force, and mass resulting motion. Okay, so report overview. The theory, they define the hysteresis phenomenon, and they do the simulation of it. And in observation, they observe some unstable phenomenon in such a point like a boot is. And in the experiment, they might be some fatigue, and they do the XT plot, and there is some force gap, and his hysteresis didn't observe in certain conditions like K is too small, and where if K is smaller, hysteresis is inappear. Okay, so the theory, the pros of the theoretical results is they define the hysteresis, but the cons is the simulation isn't straightforward. They didn't display their formula about their simulation. And for observation, they check the phenomenon and point out the direction of research. But they didn't have quantified theory, and they didn't consider the fatigue of the spring, and there have no equation about the quantified theory. So in an experiment, they do a lot of experiment and show the trend of it, but the video of the setup is no need, and they didn't show the video of spring motion, how the spring is in motion, and they didn't give the qualitative explanation, and the unstable seems to cause by fatigue, and there have no error bar. So this is my discussion point. So I want to discuss with the point. So the first one is how did you define your force gap?
Force gap. Can I use this platform? This is our forcing. And if we stretch the two spring to this point, we step 2 point, and we step in this time wait a moment, and it will become this line, this horizontal line. So and keep stretch to a symmetrical spring, and then relieving in some displacement, and recall the force in a two different times.
Okay, so you use the force sensor to determine the M. There's a mass on it.
No, there is no mass.
There is no mass.
Yeah, but so in our PT, you can see there is a mass in there. So I thought it's our error.
Okay. So you only attach the spring into the force sensor.
For this force sensor, so this experiment is we want to know if there if spring cause the hysteresis phenomenon. Yeah.
Okay. So did you consider that the spring will fatigue?
Yeah, consider.
So if the spring fatigue in your experiment.
Yeah. So I saw.
Yeah. So did you know what is fatigue is?
You say
this
is non-linear and
and there's some non-linear and this.
Sorry. I said no because
no.
Our displacement not too big.
So did you verify if the K is not non-linear?
Sorry, I can.
So did you verify there's no this
Yes, because we saw this distance is 0.5 centimeters. Every horizontal displacement.
So you mentioned that. So you mentioned that the force gap is like you push the spring and the pull the spring. These two forces is not the same,
Yeah.
right?
Right.
So what caused this force gap?
We saw maybe the potential energy of the spring will transfer to the key energy. So yeah. So when it returns to the same displacement, the energy will be less than the initial stage.
So the heat energy caused the force gap, right?
Yeah, we saw it.
And the force gap caused the hysteresis phenomenon.
Yeah, because you can see the energy in this system wouldn't be in the sun stage. So we thought it will cause the unstable equilibrium programs.
But what is your theory of this? What is your theory of this experiment or this problem? Your theory.
But
How to simulate it?
simulate.
You do the simulation, right?
Yeah.
So how to simulate it?
We use and simulate to simulate it.
You didn't show the
Yeah.
you didn't show your equation about the simulation.
Yeah.
So what is the simulation? What is the theory?
What is the theory?
Yeah. So it is like it is like this, right? And
Yeah.
there's you know math, you just say the f of t, right? So
Yeah.
it's a force sensor.
Yeah.
Okay.
So what should we do this?
Okay. So in your simulation, there must be like an equation of it, right?
So you say our experiment lack theory to improve our experimental data. Is it your question?
Yeah. Because you didn't display something, you didn't display the phenomena. So like like this, F equals to the spring constant times the displacement, right?
Mm.
So in this case, we should define the x and y, so that and find the position of it. So we can find this one, the length of this one and the length of this one,
Yeah.
and we can see that there's a force.
Of
Right.
spring. Yeah.
Yeah, of spring. So we have the equation of F equals to ma, and
Yeah.
F is your force sensor. Your force sensor apply and plus the K times L1 minus L0, which is
So what okay, can I see your question? What is K? What is this value mean?
just this force.
What is plus? They are in a different direction.
Oh yeah, so it might be a
Might be a zero?
Might be a vector, yeah. So it's different direction. So here might be a vector, but I don't have some. Just a vector, yeah. So it is a vector and the plus something, and it is also a vector equals to ma, and your m is 0, so it's equal to 0. So you have this equation, right? So
Yeah.
the simulation is applied by this equation, right?
Yeah. That's right.
Okay. So in this case, you didn't
So we thought the problem statement want to do is to investigate this phenomena, not to not to
Calculate it.
yeah, not calculate.
Okay, but your simulation didn't match the simulation and your experiment is inconsistent because like it's not the same. Yeah, and
Because the energy is not the same.
yeah, because in this case the energy is conservative because this one is conservative force, but in your case you have produced some heat energy which is not conservative.
Conservative.
Just okay. What is conservative? It is like kinetic energy and potential energy equals to constant. So
Yeah.
for this like F equals to negative. If F equals to negative differential of the potential energy, we call this F is conservative. And in the spring, we have equation of U equals to half kx squared. So we have F equals to negative kx. So F of the spring is conservative. So in this case, this force is conservative except for this. So like the work done by your force plus the energy plus the like potential energy is the constant. The force, the work done by the force plus the potential energy is constant. So there's no heat. But in
So you thought in this section there would have a heat energy.
Yeah, in your simulation and your experiment result, it is not consistent because this is your simulation
this is according
and
to
there's no heat energy.
This is according to our the first experiment. So we started with energy to this because some displacement, our flowing and releasing energy are the same.
Okay, so the heat energy and it causes the force gap and force gap causes hysteresis. So the simulation didn't have the heat energy. So the simulation.
So you suggest to plus the heat energy the value of heat energy.
Yeah. So you didn't do any simulation.
Okay.
So if the simulation. So if in simulation there's no hysteresis result, right?
No. I thought in. This is your theory now, my theory. So we thought in our theory this will impulse the heat energy value to.
Okay. So in your simulation you have heat energy.
Yeah.
Okay. Next question. Okay. So. Did you measure your K?
The K, yeah. You said the K consistence of spring.
Yeah.
Yeah, we did.
Okay. So how did you investigate the equilibrium point?
Equilibrium.
Yeah. Where's the equilibrium point?
Because in this diagram.
Time is up, so let's move on. The opponent has 1 minute to summarize the discussion.
Okay. We discussed with the reporter about the spring hysteresis, and we verified the definition of a force gap, and it is caused by some heat, and the force gap could cause the hysteresis phenomena, and they didn't show their simulation theory. So I didn't know how heat energy is applied to the simulation, and they should find some the XY coordinate of the force sensor, not mass, and the simulation and the experiment is not consistent because the heat energy they I don't know how to apply on it.
Okay. So the reviewer, you can ask, you may ask questions. 3 minutes.
Okay, I'm the reviewer from the variable 2, and because you two just not focus on this report, so now I'm going to ask this one. So first I want to ask the reporter, you mentioned that when the delta x is smaller, hysteresis is apparent. So, but we don't see any boundary for this, so can you explain that?
What? X is smaller. Which one? So this picture.
No, it's next. Where?
This one.
Next, I want to ask the opponent that do you really think that the report didn't consider fatigue, and can you find out the evidence for this?
But he doesn't consider what?
The fatigue.
Okay, so I think that the K, they should verify that there is no fatigue by to measure the K is not changed after they do their hysteresis experiment.
Okay, got it. And I want to ask you both that what do you think about energy transfer, and can you please answer briefly?
I think that there's some heat energy produced by like air, like some resistance in the spring, and so there's some heat energy produced by it, and that then in turn cause the hysteresis
Okay,
result.
thank you. And,
I agree with the last one.
okay, thank you. And I want to ask both that what actually do you two really think that will cause, what will cause hysteresis?
I think in their experiment, they should apply there's some change in the force, and change in the force that could cause the hysteresis phenomenon.
Okay,
We saw the size the parameter is changed just like the force. If we change the force to make the mass to the critical point, and there will happen a settling vacation, and in that way there will happen the hysteresis phenomena, because in this system there have two there have unstable point in the system.
that's all my questions. Thank you.
So the reviewer, you can have 2 minutes to reply. reviewer, please take the floor.
Okay, I'm a reviewer from variable 2, and their main point is the V-shaped spring and the mass resulting motion and the adjustable extra force. And okay, there's the reporter strength and weakness. And the reporter strength is they have complete theory and there's key points and clear explanation of the phenomena and formula. But their weakness is could speak clearly and no error bar and give clearly explanation. And the opponent's strength is precise question and good analyze. But their weakness is should guide the reporter further in the discussion and should be more precise and clear. And our suggestion is that use hands to stretch, and we think that is inaccurate. And the opponent shouldn't focus on only one part too long. And here's a discussion the opponents ask historians parts of system energy to convert into heat energy. What do you mean? And the reporter answer, we assume that. But we think the reporter should provide evidence or calculate the energy transfer. He later said that it will cause the force gap and it will cause to hysteresis. But we think that is contradict. And for a discussion, the opponent asks to define the force gap and what causes the force gap, and the reporter say we assume parts of the system energy convert into heat energy. But we think that we need theory to support and correlate it with their theory, please. And the opponent asks, experiment didn't match the simulation, and the reporter answer, that's not our theory, we add heat energy. And I asked what called hysteresis, and the reporter said the parameter change and it will cause change force and it will go hysteresis. And the opponent say that it will change in the force. So that's all my review. Thank you.
This is my conclusion. So first, we went through the spring tube over, so the fatigue of the spring won't influence that. And the observation and experiment is different on the way of external force. And the observation part only control the mass and release it at once. And in the experiment, we use the force to follow the connecting point and all time. And in the experiment, we only pull and release the force. We don't push. For the simulation, we assume the key existence, but we didn't calculate it. So thank you for suggestion. And there are parameter change in the system like heat energy and extra force, so it can cause to hysteresis phenomenon. This is our concluding remark.
Okay, now time for jury to ask questions.
So the problem statement maybe movement is not limited in one dimension. So when the report is in one how to stack into the movements in two dimensions. That's what
So the ball is in the y-axis. Because our extra force is vertical to pull the mass energy same, the two springs are the same spring, and so the force from the spring are the same, and its horizontal force is the same. So the ball will, and so the ball we control it in a vertical motion.
Well, it's like, as you expectation, it's not limited. How long is it focus?
I think that I think that there must be like the horizontal displacement, because if the force is the same and is symmetry, there is only one direction. But if the diagram is like this, so this is not symmetry. So there's a horizontal displacement of the force sensor, and that this force and this force could not be symmetry. So so 2D system is more accurate.
I think that the report just discuss the one direction, but when the force is from different direction, it will cause different situation.
And if our system is come to this one, and we saw the motion of the wave of the mass, we will be this one. That's why this, and then it will be smaller, and then we will change to the next direction. So we saw that you will be in this direction. And we stretch the ball in this displacement, and then we just open my hand and make the ball to move. So you will come to this line. There's my point.
So from the statement of the question, it says under certain conditions, so the motion of mass depends on the history of change of the force. So I want to ask, do you think that under what condition it will happen, or it always happen? Because in your discussion, I think you focus mainly on the loss for the heat.
We saw. Just like our simulation, we saw when our force, when our extra force come to a special value, and the ball isn't in the displacement, and it will come to another displacement, another location. So we thought this is a hysteresis of the ball.
So what do you think?
The reporter, in the reporter experiment, they mentioned that the heat caused the hysteresis. So in their opinion, I think in their experience, the cause of the hysteresis is due to the heat energy.
So it always happens. The hysteresis always happens.
The what?
The hysteresis.
Hysteresis. Okay.
Always
Okay.
happen.
It's always happens. Because I cannot use my data, so I can only use their data. Their data prove that their data suggests that the heat energy, if there's a heat energy loss, then they will cause the hysteresis.
Although time is up, but I use my power to ask the question. So the the problem is that you need to make a spring combo that is V-shaped, right? So what's the effect of the angle suspended by that two springs? What's the effect on your hysteresis, or if there's any? So, and three of you, that's a question for you.
Could you restate your?
Yeah, you have a V-shaped spring combo, right?
Yeah.
And there's an angle subtended by that two springs, right?
Oh, yeah.
So what's the effect of that angle?
We start it will close to if we change the distance in this one, we define we start there will happen unstable point in a different extra force we use.
Okay. So any answers? Just show answers.
I think the V shape, the angle of this will, because the angle change, so the horizontal list x will change. So, and we think that when x is smaller than the initial length of the spring, and it will go into three equilibrium. So when the x is smaller, or the x is smaller, so when it's the range of the three equilibrium will be smaller.
So I think the angle of the V shape, it will affect the force. Yeah, so it will affect the force of the spring, and there's some extra force. So like she said that the extra force and the two spring that cause the three equilibrium points. So I think the angle of it will affect the force about it.
Okay, thank you. So my second question is kind of unconventional. So you guys, in the first round, you did air muscle, right? 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 You guys all were there, were here. And so I want to ask you, three of you, what's the difference? Of course, I won't ask similarity. What's the difference between, or what's the similarity between these two questions, these two problems? Air muscle and this V-shaped spring.
We start air muscle because the balloon is an elastomer, so it will be bigger and smaller. So we start if we come to the sun displacement when we bigger and smaller to the sun displacement, it will be the same force in this time. So I thought this is the air muscle and the hysteresis phenomena we connected to each other.
So I think the air muscle might be some hysteresis because of the, if we pump the air, like increase the pressure of the muscle and then decrease the pressure of the muscle. The condition is the same, but it due to the history of the whole process, so the result might be changed. So the air muscle might be some hysteresis phenomenon.
And I think it's the same as the argument because the air muscle, if the air muscle happen the hysteresis, and it will, when we do the same thing to the air muscle, and we think that it is happen at hysteresis, it will have different situation as the same thing that we put into the air bubble. So is that.
Okay. Yeah. Ari will extend in the discussion. So it's time for jury to give scores. Jury is ready. Scores for the reporter. 5, 5, 6, 5, 6. Jury for the opponent. 6, 6, 6, 6, 7. And the jury for the score for the reviewer. 5, 6, 6, 5, 5. Okay, that concludes this session.